Hello all, welcome back to my YouTube channel Mukesh Jacob. So in the continuation of the competitive programming for the interview preparation for the toughest data structure problems. So today's problem statement is given an array and integer k where k is smaller than size of array. The task is to find the kth smallest element in the given array. It is given that all array elements are distinct. So problem statement says is we need to find out the smallest element from this array while passing the value of k. So for example, if I'm passing k equals to 3, so here third element should be written. So according to the array, if I will sort this array, so on the third position, shortest element would be 7. Alright. Okay, so let us move to the coding editor and I will code it live. Alright, problem statement is already cleared and I have mentioned here also. So if you need more understanding here, you can read it one more time. Just pause the video and read it once again. So here few parameters I'm considering. Array equals to given array, L equals to starting index, R equals to ending index. So ending index would be size minus 1 or starting index would be 0 and k is the kth element that we need to find out. So this given problem can be solved efficiently using the quick select algorithm. So there is a one algorithm quick select. So this algorithm is used to find the k the smallest element in an unordered list. So you can see the given array is also unordered. Alright. And few assumptions we will take, few criterias we will consider the pivot element, but instead of sorting the array directly we will do the partition of the array in the two parts and accordingly we will sort only the one part. All right, so let's move on to the coding part. So let me create a class called as solution. All right, let me define a function def k smallest element. All right, let me pass the parameter array starting index, ending index and the position of the element. All right, so as I mentioned, we need to partition the array, right? So first let me put the input so we can understand. Okay, so here array equals to not array, yeah, array equals to 7, 10, 4, 3, 20 and 15. This is the given array. All right, now we need to partition this array in few parts. All right, so for partitioning, let me write first that code for the partition. All right, so let me write a function called as def partition. All right, it will accept few parameters: self, array, starting index and ending index. All right, now we have to choose the rightmost element as a pivot element. So first, pivot element selection, we need to select the pivot element. What's the issue here? Okay, because we haven't completed the this one. Let me do one thing. All right, so first we need to select the pivot element. So for pivot element selection, let me initialize one variable pivot equals to array of r, that is the ending index size minus 1. Alright, now we need to find out the smallest index. So smallest index of the, not the smallest index, index of the smaller element. So I equals to I minus 1, not exactly I, L minus 1. Alright, now let me run through a for loop for j in range L comma R. Alright, and I'm taking here left and the right index for the elements. If array of j less than equals to pivot element, if array of j less than equals to pivot element, okay, unexpected indentation, yes, okay, if array of j less than equals to pivot, then what we have to do, we need to increment the index of the smaller element by 1. So I plus equals to 1, right? And after that we will swap array of I and array of j. So array of I comma array of j equals to array of j comma array of I. Alright, swapping is done. Now what we have to do, again we need to swap the I plus 1 and R, the right index, to put the pivot element in the correct position. So what does this mean? Array of I plus 1 comma array of R, that is the ending index, alright, equals to array of R comma array of I plus 1, and from here we will return the position of the pivot element. Return I plus 1. Alright, so what we are trying to do here, we are just doing a partition of the array, and from that one we are just returning the exact position of the pivot element. Alright, so this partition function is completed. Now let's move to the our main function, that is the smallest element. Alright, so first we need to write the base condition. If k greater than 0 and k less than equals to the ending index minus L plus 1. Okay, if this is the base condition, then partition the array around a pivot element. So what we have to do, position equals to self dot partition, just pass array starting index and the ending index, right? This is the first condition. Alright, now if the position of the pivot element is the same as the element, for example here k is the kth element, so let's say I'm giving the, I need to find out the third element, smallest element from the array. So if this element and pivot element, if both are same, then what we have to do, then we also check that condition. If position minus L equals to k minus L. Alright, from here what we have to do, return array of that position. So what happened here, we are just checking if the position of the pivot element is the same as the k, then return the pivot element, then directly we are returning the pivot element. We need to consider one more condition here. If the position of the pivot element is greater than k, then what we have to do? In that scenario, we have to recursively search the left subarray. So let me use elif position minus L greater than k minus L. Alright. In this scenario, what I have to return is return self dot k the smallest element providing the array comma starting index position minus L the ending index and the case element. Alright. One more condition here is if the position of the pivot element is less than, if pivot element position is less, in that scenario what we have to do, let me write one else condition, directly return self dot kth smallest element, just pass array comma position plus starting index comma position minus L position plus L. Okay, no, again it should not be, we need to pass ending index comma k minus position plus starting index minus 1. So here also position plus 1. Okay, and apart from this scenario, if anything comes, then just return none. Return none is okay if k greater than 0. Okay, this should be indented here and return. Alright, so let's run it and we will see what errors will appear here. Okay, so for that one, what we have to do, we need to just call this function. So for that, let me create an instance of this solution class. Let's say k equals to 3, r equals to len of the array minus 1. Alright, now result equals to solution dot k the smallest element and pass the array comma 0 starting index, ending index and the kth element. Alright, and use the print statement and just put the result. Okay, we'll see. Okay, so here what's the error? Error says maximum recursion depth exceeded in comparison. Alright, so here I plus 1 for loop. Let me verify it. Here range starting from 1 comma r. All right. Okay. Let me debug this one. So array of I+1 for j in range. Okay. For j in range, it should be L comma R. Maximum recursion depth. Okay. So here I'm returning I+1, array of I+1, array of R, and I+1. Okay, I plus equals to 1 if array of j equals to pivot. And pivot equals to array of R. Okay, now so if position minus L and it should be k minus 1. Here also it should be k minus 1. Let me recursion depth exceeded. Okay. Now the base condition is R minus L plus 1 self partition. So we need to debug this error for j in range n L comma R. So it says line number 32 for j in range L comma R. L comma R. Okay. Array starting and ending array of R I equals to L minus 1. Okay, for j in range L comma R if array of j less than equals to pivot I plus equals to 1 array of I, and now we are swapping back and returning I plus 1. This is the correct. Okay, let me check the above condition. Self dot k the smallest element array position plus 1 comma R k minus position plus L minus 1 and return self dot array comma L position minus. Okay, it should not be ending index here. it should not be ending index. Okay, let me try to execute this one. All right, so what I have done here I just pass the ending index. Guys, it should not be ending index because ending index is the L. So just to debug it, I tried from the ending part from the partition and I check what is the L is coming, and it should not be out of the range. So here it should be position -1 because we are considering the smallest element. All right. So here it says the third element is 7. So now let's look at the our input array. So here 7, 10, 4, 3, 20 and 15. So third element would be 3, 4 and 7. Exactly, it's the correct one. So let me execute by changing the position of this k element, k equals to 2. So it says second is the 4. That is definitely correct. All right, so this was the solution, guys, for solving the problem statement where we need to find the k, the smallest element. Okay. Okay, so thank you so much, guys, for watching.